Welcome back to the Math Professors. If you enjoy content that can be found in any college math class, please consider liking, subscribing, and sharing. I'm Professor Van Hamlin. I'm going to cover the determinant of a matrix. So we'll mostly do 2x2s and 3x3s, and if we have time, maybe I'll expand it more, but we'll probably end at 3x3s and then save that for another video. So first, if a matrix is a square matrix, then there is a unique value called its determinant. So really I'm saying that every matrix has a determinant, and that determinant is unique to that matrix, assuming that matrix is square. Now, if matrix A is a 2x2 matrix of the form here, so, element in the first row, first column, first row, second column, second row, first column, second row, second column. Then the determinant of A can be defined by this determinant of A, or we sometimes write it looks like an absolute value sign of A. So this says determinant of A, this says determinant of A. And it is found through a multiplication by going, really, you kind of X through the matrix. So A11 times A12, so you're multiplying in this direction. You can see that. And then what you're going to do is you're going to subtract and you're going to multiply in the other direction. So when you subtract, you're now going to multiply in this direction. So an example of this, let's say compute the determinant. Say A, the first one is going to be 3 minus 2, 1, 5. And let's do maybe another one. Let's say for B, let's call this matrix B, is going to be equal to 2, 7, minus 4, minus 14. Let's go minus 7, make this positive 14. Okay. So if I want to find the determinant of these matrices, I just have to, multiply across. So we know we have to multiply the main diagonal. So this is going to be equal to, 3 times 5. So say the determinant of matrix A is going to be equal to 3 times 5. And then we're going to say minus, we're going to have to multiply in that other direction. So we're going to have to multiply this way. So minus, we're going to have that negative 2 times 1. So the determinant of A, or I can say the absolute value of A if we want to write it that way. This says determinant of A, it just has that same notation. So this is going to be 15 minus a minus 2, so 15 plus 2. So the determinant of A is going to be equal to 17. Very similar, if I want to find, say, the determinant of B, or if you prefer this notation for determinant, a lot of students do because it's less writing, we know that we're going to have to multiply this main diagonal. So that is going to be 2 times 14, and then we're going to have minus negative 7 times negative 4. So we're going to have 28 minus, well, negative is negative is a positive 28. So in this case, this determinant is equal to 0. So now let's figure out how to find determinants of 3x3 matrices, and we have to set up cofactors. So in order to determine 3x3 matrices, so at least they're determinant of 3x3 matrices, we're going to really need to know what cofactors are. So we'll start out with the minor. The minor, Mij, of a matrix is the matrix formed by deleting the ith row in the jth column. The cofactor, which is going to be related to the minor of a matrix, is defined to be Cij, which is equal to negative 1 to the I plus j, times the minor of that same location. So, so if I want to find the minors and the cofactors of, say, this matrix A here, what I've done is I've given a couple locations. So we have, I want the minor 2, 1, and then the cofactor 2, 1. And I'm going to find the minor 3, 1, and then also the cofactor 3, 1. And maybe if we have time, we'll do maybe one more to make sure that you understand what we're doing. So if I want to find the minor 2, 1, what I'm asking for is I'm asking for the second row first column. So I'm asking for the minor of that location right there. That is going to be second row first column. So what we're going to have to do is we're going to have to delete that row and then also that column. So let me make sure we can see what we're going on here. So 2, 1, 3, negative 1, 2, 4, 0, 1. So I want to find the minor of this location here. And what I'm going to do is now I'm going to delete that thing's row. And I'm also, so row and then also its column. And then that means the minor is going to be the matrix that's left over. So M21 is going to be equal to 2, 1, 0, 1. Now the cofactor is, it's related to the minor, it's just a multiplication. So the cofactor 2, 1 is going to be equal to negative 1 to the 2 plus 1 multiplied by this minor. So this is 2, 1, 0, 1. So negative 1 to the third power is going to be negative 1. So the cofactor is nothing more than the opposite of this matrix. Now you're welcome to distribute that negative sign through all those elements. So all those things would become negative, but really just making sure that we know that its sign is going to be negative. Now if I want to find the minor of 3, 1 and also the cofactor of 3, 1, we know that the minor 3, 1 is going to be equal to, well, I'm doing this. This is going to be third row first column. So I'm going to delete that row, delete that column. So we know we're going to have 2, 1, negative 1, 2. And then the cofactor of 3, 1 is minus 1 raised to the 3 plus 1 multiplied by that thing's minor. So negative 1 to an even power is going to be positive 1. So the cofactor in this case is going to be 2, 1, minus 1, 2. All right, so now let's figure out what the determinant of, say, a 3 by 3 matrix is, which may be this one right here. And what we're going to do is we're going to use minor. We're really going to use cofactors to be able to do that. So let me give you a way to find the determinant. So if A is a square matrix of order larger than 2, then its determinant can be computed by this. So the determinant of A, or the determinant of A, is going to be the summation from j equals 1 to n of A1j times the determinant of that cofactor C1j. So it'll be A11 determinant of C11, A12 determinant of C12, all the way up to A1n determinant of C1n. And we'll see as this is really a row 1 expansion is what we're going to call this. You can see that because these are 1s every single time. So what we're going to do is, let's talk about this mean. So this is going to be A11 times the cofactor of A11. So A11 being right here, right? And then we're going to do A12 cofactor of A12. So then we're going to have to do this one next. And then all the way up to this one as well. Now this goes all the way up to A1n. So what if this is a 4 by 4 or a 5 by 5 and so on? So in this particular case, it's just going to go to A13, the determinant of C13, because this is a 3 by 3 matrix. So if I want to find the cofactors, well, what I know is that cofactor 1, 1 is going to be equal to minus 1 to the 1 plus 1 times, well, I actually want to find its determinant, right? So it's going to be the determinant of this thing. So this is going to be, the determinant of well, when I delete this row and then this column, we can tell that this row is going to go away every single time because we're in the first row for every single one. So I'm going to get that 2 by 2 matrix. So this is going to be determinant of minus 1, 2, 0, 1. Now we're also going to have to find the determinant of C21. So this is going to be minus 1 to the 2 plus 1 times the determinant. Again, that top row is going to go away. That middle column is going to go away. So 3, 2, 4, 1. 3, 2, 4, 1. And then finally, I'm going to have to find the determinant of C31. So this is going to be minus 1 to the 3 plus 1. Then the determinant, cover up that column. So 3 minus 1, 4, 0. So what we're going to get is we're going to get minus 1 squared, which is just 1. So the determinant of this is going to be minus 1. So minus 1 minus 2 times it's going to be 0, so this is going to be negative 1. Same thing here, this is going to be 3. Well, negative 1 to the third power is going to be minus, so this is going to be 3 minus 8. So this is going to be equal to a negative 5, which would be equal to 5. And then this is going to be equal to minus 1 to the fourth, which is going to be an even power, so it'll just be 1. So then 0 minus this, minus 4, which is going to be equal to 4. So that takes care of, these pieces here, essentially, right? So now I still have to multiply, 0 times its cofactor. So the determinant of A is going to be equal to, 0 times its cofactor, which is right here, which is going to be minus 1. Plus, we're going to have 2 times its the cofactor, which we already computed, is going to be equal to 5. Plus, now 1 times its cofactor, which is going to be equal to 4. So what we get is we get, 14 when we're done. Now, we tend not to do this work separately, so a lot of times when we ask for the determinant of A, what we do is we say this is 0 times, what we actually should talk about as well is what about the signs of the cofactors? So if I have a 3 by 3 matrix, this is going to be location 1, 1, this is location 1, 2, this is location 1, 3. So negative 1 to those particular powers, well, 1, 1 is going to be a positive number. This one we could tell was negative, right? So this would be a minus. And this one right here we could tell was going to be, a plus because negative 1 to the fourth was just 1, so plus. So it really checkerboards itself kind of out. So that's kind of like if I was going to find the cofactors, that's going to be their signs of, those determinants. So it's going to go plus, minus, plus when we're going to do that first row. So usually when we do this, we don't write it all out. I just say plus. Now it's going to be the determinant of minus 1, 2, 0, 1. And then minus, it's going to be the determinant of, sorry, this is 0 times that because that's 0. Minus 2 times the determinant of 3, 2, 1, 4. 3, 2, 1, 4. And then plus, it's going to be a 1 times the determinant of 3, negative 1. And then we can see that this is, 0 times negative 1 minus 2 times minus 5 plus 1 times 4. And then you can see that we get exactly the same thing, which is going to be equal to 14. All right. Now what we did is we did what's called a row 1 expansion, but we can actually do any row expansion and any column expansion. And I will write their notation in here, but we're not going to spend much time exactly on the notation because we can see exactly how this notation works for this. So let me write an ith row expansion, then also a jth column expansion, and then we'll find a different row and also a different column expansion and just verify that we get 14, both times. And that'll do it for this one. So here are the formulas for an ith row expansion. So what we saw before is it looked just like this for the previous equation. Instead of saying I, it said 1 in all those locations. And it doesn't have to just be the first row. It can be any ith row. And then very similar for this, we can do a column expansion. And we can see that now that the columns are the things that are changing. So let's do this exact same matrix. We already know its determinant is going to be equal to 14, but let's do a different row and also a different column and verify that we still get a unique answer for its determinant. So when we go after this, I want to do, first we're going to do the second row expansion. So I'm going to write A right next to it, so then when I do a column as well, it won't look as messy. So first we're going to do this expansion here. We're going to do a second row expansion. So I know that the determinant of A, or if you prefer to write it in that notation, remember that the way the signs go, it goes plus, minus, plus, minus, plus, minus, plus, minus, plus. So in this case, if I'm doing this, this is going to be minus the determinant of its minor, and this is going to be plus the determinant of its minor, and then minus the determinant of its minor because of that minus 1 to the I plus j. So what we know is this is going to be equal to 3. Well, actually, I'm sorry, it's minus, so we're going to have minus 3 times the determinant. Now, when I cover up that column, 2, 1, 0, 1, 2, 1, 0, 1. Now, plus it's going to be that negative 1 times the determinant of covering up that column, 0, 1, 4, 1. and then it's going to be minus this 2 times the determinant of 0, 2, 4, 0. So now we're going to have minus 3 times 2 minus 0, so that'll be 2, minus 1, and then this is going to be 0 minus 4, and then minus 2, this is going to be 0 minus 8. And if we did this correctly, we will get 20 minus 6, which is 14. Now, let's do a column 3 expansion. So now we're going to work with column 3. Now this is going to go plus minus plus for that negative 1 power. So determinant of A is going to be plus 1 times the determinant. Now I have to, in this case, remember we're deleting that column regardless. So now we're just going to go after the rows. So deleting this row, 3, negative 1, 4, 0. So 3, negative 1, 4, 0. Now this is going to go minus that 2, determinant of, cover that row up, 0, 2, 4, 0, 0, 2, 4, 0, and then plus, plus this 1, covering up that row, 0, 2, 3, negative 1. 0, 2, 0, 2, 3, negative 1. So this is going to be 1 times 0 minus a minus 4, which would be 4, minus 2 times 0 minus 8, plus 1 times 0 minus 6. And again, we'll know if we did it right because every it has a unique determinant that is the same regardless of how you compute it. So, if you like the content, please subscribe.